This is a continuation on the previous question to do with creating a hashing function. If you haven't seen that video, do watch that one first. Pause the video and give this question a go. Okay, so really what I'm going to do is just remind myself that we've got A, B, C, D, E, F. And I'm going to go up to F because it's the last letter here. That A is 65, B will be 66, 67, 68 in terms of ASCII value, 69, and 70. And that we've learnt that through our hashing algorithm, we'll take away 64 from each of these to give us our position. So we've got file F. F is 70, take away 64 is 6. Therefore, we're going to put file in here and its German equivalent in here. And I'm going to try and pronounce that. Okay, we've then got disk. Disk is 4 if you take away 68 from 64. So disk, and that is a platte. Very nice so far. Okay, we've then got E, which is 5, so we're going to put error in here, and the German's fella. And finally we've got computer, which is going to go as 3, so computer, which gives us Rechner. Very nice. Okay, so we've got Rechner, blah 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 blah. So this question is actually done already, nice and easy, 2 out of 2. Let's have a look at the next bit though. So what you can see now is there's a new question which I've added, which basically is saying another procedure call is made saying add drive. What is the problem when we add this key and this value to this dictionary? Explain the problem. Pause the video, give it a go. So what you should have mentioned is that there would be a collision which occurs, and by this it would most likely overwrite the previous key, which would lead to an issue if we haven't got an algorithm to solve it. So if you get a collision, it will overwrite the previous key value, so disk would be gone and drive would be entered. So how would you handle this collision? What would you do? Okay, pause the video, give it a go. So I'm hoping you would have mentioned that you would do some sort of linear search to place, and we're going to call this an overflow, at the next available address. So if we are here, instead of putting it into 4, it'll go to 5. 5's full. Let's go to 6. Yeah, let's put it in there. Okay, so what you need to do now is write some pseudocode to implement how we're going to deal with the collision, i.e. linear search. Now, please bear in mind that the size of our array or dictionary is 2000. Keep that in mind. Pause, give it a go. So what I'm going to do is I'm going to put it into line 21 because it does ask what line you put it in. And what I'm going to put here is while dictionary index, which is hash, so whatever they type in, 1, which is going to be the key. So whilst the key is greater than empty, that basically is saying whilst we've got something inside of here. So whilst it's not empty, basically, we are going to increment our index equals index plus 1. So remember, if we type in A, and A is, after we do our hash, A becomes 1. And we check 1, but 1 isn't empty. We're going to change it so that our index no longer is 1. Even though A is 1, it's going to change it to 2. If our index is larger than the 2000, then what we want is index to become 1 again, so it wraps around, and if, and while. So, this is going to loop and it's going to go through each element. If it finds an empty spot, then what's going to happen is the loop's going to break, because the loop's going to keep looping as long as whatever's inside it is empty. As soon as something's not empty, the loop will stop. It will then do this, what I've just underlined.